2017, this was a nice one. It was set by the Giants. Question 1. So yesterday we packed 2018. Now the only good part of revision is that you cannot revise what you revised. What I mean is that even if we have so much time, if we do a paper, you cannot really do it because we have the videos. So if you have forgotten something, you go and watch the video. So question 1A, and I'm very sure that if we finish 3 papers and you are serious, you can get a paper and finish it alone without any help. Because even in this paper, some things you will see that it's a direct revision. Question 1. Let A be equal to -2 to 3. B, hello.
How about the last 2 questions in 2018? The one for 2018.
Find the radius and the center of the circle. We don't have circles.
Okay.
Find 2 positive numbers whose sum is 30 and whose product is maximum. That one is an exercise.
15 and 225.
That's wrong. Those numbers are always equal.
Yeah, 215, sir. I mean, X is 15 and then Y 15. Then the product should be 225, if I'm right.
Okay, then that's correct. Find A complement union B intersection C and display the answer on the number line. Solution. Let A run from -2 to 3, B -1 to 10, C is an integer. X is an integer from -2 to 15. And then find a set A complement union B intersection C. So A is here. So its complement is actually -infinity up to -2. Since -2 is included in A, it won't be in the complement. Union, since 3 is in A, it won't be in the complement. And then B is there already. So just go straight -infinity to -2, union 3 to infinity, union B, -1 to 10. This is one thing. Intersection C. Now C is -2 to 15. Both included, keeping in mind that these are integers. So from -infinity to 1, get the union here. The union first, then the intersection. So they left this guy versus this guy. -infinity is the least, all the way up to -4. There's a gap there. union. This guy starts at 1 all the way up to 10. So picks it up infinite. So you got infinite. And then this thing now, intersection, -2 to 10. Then I'm going to have, as you can see, -2 is not here. So it can't be intersection. -1. So -1, -2. Included union of alpha from -1. Okay, from -1 to -2. -2 included. Yeah. Union this is that's why I got confused. The solution here is C. Exact. Let's do the line. This guy runs from -2 up to -4, going inside. Then it starts at 1, going inside. Then the other guy starts at -2, including but x is an integer. So the intersection is from here. So our solution is not C. Our solution is equal to. So the set show the number is going to show. And then it is -1 all the way up to 15. Because of the integer set, already as an interval, it was finding it equal to 15. So if you get an integer such that -1 is less than or equal to x, less than or equal to 15. This is the solution. The difference is that integers is -1 going to an integer.
Yes. No. No, sir. No. Even an integer.
What is an integer by definition?
Sir, I think integers are numbers which contain the negative and positive signs.
We have put a negative one. Integers are positive, negative, plus 0, all numbers. So that's the reason why I'm emphasizing here. This intersection is not a broad line like where I just say -115 and keep quiet. Because this then means that it's in R, and R is negative. Root 2 is in R, but root 2 is not an integer. That's why there is just distinction there. Okay. Some have saved it. That's why it says you have to go answer sets in a very, very simple. Given x is a subset of y, and x is a subset of z, section y intersection z. Display on the Venn diagram. Cannot display and intersection y intersection z. This is going to be the display. We have information here: x is in y, x is in z. So you can choose to do this to avoid confusion. This is x, this is z. Then place y separate. It is x complement, it is in y, it is in z. So to avoid confusion, X will be denoted inside. So that's the solution. Given that C intersection D is empty, simplify the following as much as possible. C union D intersection C complement intersection D complement. So you say this is the same as C union D intersection. You write it. No, I can't take the complement outside. So intersection C complement intersection C union D intersection D complement. We've done distribution, this one intersection this, and this one intersection that. Then from here, can distribute C intersection C complement union C complement intersection D, and then intersection C intersection D complement union C union D now D complement intersection D. Now you know that C intersection C complement is empty. This is empty. Union C complement intersection D intersection C intersection D complement union. This is empty. Put empty. So empty union anything is that thing. So C complement intersection D intersection C intersection D complement. Now if C intersection D is empty, if you have CD intersection is empty, then C complement intersection D is just D, because this is empty. There's nothing here. So C complement intersection D will just be this one. And since the other space is empty, then you're saying C complement intersection D is just D. Intersection C intersection D complement is just C, which is empty. Well simplified. As much as possible.
Sir, how about, I don't know if that's too shortcut, where there is a C complement intersection D complement, whereby you say it's an empty, then you say
Or just
C
huh?
union.
Where is it?
Where is what is here? C intersection C complement
This
intersection
is
D
empty.
complement. You say empty.
Mhm.
Then this part I will not say I'll have C union B. Then you intersect it with an empty. Then probably to give you an empty set. Is it that too shortcut, or is it just okay if you to write it as an answer in the exam?
That's not even true. The only true thing is that if you wanted a shortcut, you would say C complement intersection C union D is going to be D. And D complement intersection C union D is going to be C, which is empty.
Okay.
But if I can't see that, then I'll have to go this way so that I'm convinced that is correct and the examiner has seen that I'm sure what I'm talking about. B. So far it's pages. I think this exam was bad. Let star be a binary operation on Z defined as A star B is equal to A squared plus 2B. A, find -1 star 3 and 3 star -1. So let's find -1 star 3 is going to be -1 squared plus 2 multiplied by B, which is equal to 1. Did I write B there? B is 3. So you put 3, which is equal to 1 plus 6, which is 7. And then 3 star -1 is equal to 3 squared plus 2 by -1, which is 9 minus 2, which is 7. Then part 2 says, is star commutative on Z? Give reason. Give reasons for your answer. To be commutative, we want A star B to be equal to B star A. Is it commutative?
Yes, sir.
What's the reason?
Because they are equal.
What are equal?
Because they are giving same number, like 7, 7.
That's wrong.
Because because A star B equals B star A.
Let's see if that is true. A star B has been defined as A squared plus 2B. Then B star A can be defined as B squared plus 3A. Is it? Is there any equality here? That was just one choice. You can pick another choice. If they are commutative, then they must satisfy every choice that we have. So suppose we have 1 star 0 and 0 star 1. Let's see if this also will be satisfied. So 1 star 0 is equal to 1 squared plus 2 multiplied by 0, which is equal to 1. Then 0 star 1 is 0 squared plus 3 multiplied by 1, which is equal to 3. So we're saying since 1 star 0 is not equal to 0 star 1. Star is not commutative. On Z.
Sir,
You know?
why the second one, B star A is equal to B squared plus 3A instead of B like 2A?
It's supposed to be 2A.
There is 2B here.
Just made a mistake, my man. Supposed to be 2. Supposed to be 2. So even here it will be plus 2 multiplied by 1, which is equal to 2. So 1 is not equal to 2. So it's not commutative. So you don't rely on the example given. You must be very careful in the exam. They'll give you an example that looks like things are okay. But then try to check using your own example if it's indeed satisfying. Determine whether or not star is associative on Z. To be associative, you require that if I have A star, B star C, it must be equal to A star B star C. Then you say there's commutativity there. So are they commutative? I mean, you say there's associativity there. Is it associative? So let's see. No example. A star B star C will be defined as, where is it? As, okay, first we can get B star C and define it as B squared plus 2C. Then take it to A, then call it P, so that when you take it here, you have no confusion of variables. We are doing it P, and it will be C squared, it will be A squared plus 2P. But what is P? P is 2B squared plus 4C. Expanded. Then the other one, A star B, we already know that A star B is A squared plus 2B. So we call it P. So we have P star C, which is P, P squared plus 2C. But P is A squared plus 2B. So it will be squared plus 2C. But this is A4 plus 4A squared B plus 4B squared plus 2C. So the two are not equal. Star is not associative. C, express 1 minus root 27 over 2 plus root 75 in the form A plus B root 3. This M3 is one we use. You get 27 divided by 3, you get 9. You get 75 divided by 3, you get 25. go back to the question and say 1 minus root 9 by 3 to mean 27, 2 plus root 25 by 3 to mean 27. So you have 1 minus 3, the root of 9, root 3, over 2 plus 5, the root of 25, root 3. Then you rationalize. Multiply by 2 minus 5, root 3. Multiply by 2 minus 5, root 3. It's going to be 2 minus 5 root 3 minus 6 root 3 plus 3 times 5 you get 15. With 3 times root 3 you get 3. So you get 45 altogether. Over 2 by 2 we get 4 minus 10 root 3 plus 10 root 3. 5 times negative 5 you get negative 25. And then root 3 times root 3 you get 3. So we get negative 75, which is equal to 2 plus 45, that's 47, minus 11 root 3 over, this gives us 0, so we get negative 71. So this is negative 47 over 71 plus 11 over 71 root 3. Plus, because there's a negative coming from the denominator, we're taking care of that negative. We've used the property that A multiplied by B is the same as root A multiplied by root B. Part 2.
A previous put forward a screenshot can scan of saving it. Oh, the previous one. Thank you.
2. Find the value. Find the value of 1 over 2i plus 1 over 1 minus 2i. This is 2i, 1 minus 2i. In here, 2i in there, we get 1 minus 2i, and then plus 2i. So this becomes 1 on top over 2i when you expand down plus 4. So you conjugate. Inside, you have minus 2i plus 4 over